How was the Sun born? The amazing story of our star's formation. Imagine a place of unimaginable scale, a cosmic cloud vast beyond comprehension. This isn't just any cloud, it's a molecular cloud, the birthplace of stars like our Sun. It's a region of space where the raw materials for stellar creation reside. These clouds are incredibly cold, just a few degrees above absolute zero. They're also incredibly dense, though still far less dense than anything we experience on Earth. Within these frigid depths, the story of our Sun begins. The primary ingredients are hydrogen and helium, the simplest and most abundant elements in the universe. But there are also traces of heavier elements, forged in the hearts of long-dead stars. These are the remnants of cosmic recycling, the seeds of future generations of stars. Our molecular cloud, though vast and dense, is relatively stable. It needs a push, an external event to kickstart the process of star formation. Something has to disrupt the equilibrium and initiate the gravitational collapse. One of the most likely triggers is a shockwave from a nearby supernova. A supernova is the explosive death of a massive star, a cataclysmic event that sends ripples through space. This shockwave can compress the molecular cloud, creating regions of higher density. This disturbance causes gravitational instability within the cloud. Gravity, the force that pulls everything together, now has a foothold. It begins to overcome the outward pressure of the cloud, and the collapse begins. The cloud, now destabilized, begins to collapse under its own gravity. It's a slow, inexorable process taking millions of years. As the cloud shrinks, its density increases, and gravity's grip tightens. The collapse isn't uniform. The cloud doesn't simply shrink like a balloon deflating. Instead, it fragments into smaller, denser clumps. These clumps are like seeds within the cloud, each with the potential to become a star. One of these clumps, destined to become our Sun, continues to collapse. It gathers more and more material from the surrounding cloud, growing in mass and density. The stage is set for the birth of a star. As the clump collapses, something remarkable happens. It begins to spin faster. This is due to the conservation of angular momentum, a fundamental principle of physics. Think of a figure skater pulling their arms in during a spin. The same principle applies here. As the clump contracts, its rate of rotation increases dramatically. This rapid spin has a profound effect on the shape of the collapsing cloud. It flattens into a swirling disk, much like a pizza dough being spun in the air. This is the formation of a protoplanetary disk, a swirling disk of gas and dust surrounding the nascent star. It's from this disk that the planets of our solar system will eventually form. The Sun is taking shape at the center, while the building blocks of planets swirl around it. At the core of the collapsing cloud, the pressure is immense. Gravity is relentlessly squeezing the material, compressing it to unimaginable densities. As the density increases, so does the temperature. The core heats up dramatically, reaching millions of degrees Celsius. This is no ordinary heat. It's the kind of heat that can trigger nuclear reactions. When the core reaches a temperature of about 15 million degrees Celsius, something extraordinary happens. Nuclear fusion ignites. Hydrogen atoms, the most abundant element in the core, begin to fuse together to form helium. This is the same process that powers hydrogen bombs, but on a vastly larger and more sustained scale. This nuclear fusion releases an immense amount of energy in the form of light and heat. The energy counteracts the inward pull of gravity, stabilizing the star. The Sun is born, a shining beacon in the vastness of space. The Sun now shines brightly and stably, radiating energy into space. It has entered the main sequence, the longest and most stable phase of a star's life. For billions of years, it will continue to fuse hydrogen into helium, providing light and warmth to its surrounding planetary system. But the story doesn't end with the birth of the Sun. The protoplanetary disk, that swirling disk of gas and dust, still contains a wealth of material. This material will play a crucial role in the formation of the planets, asteroids, and comets that make up our solar system. Within the disk, dust grains collide and stick together, forming larger and larger clumps. These clumps grow through accretion, gradually sweeping up more and more material from the surrounding disk. This is how planetesimals, the building blocks of planets, are formed. These planetesimals continue to collide and coalesce, eventually forming protoplanets. Through countless collisions and gravitational interactions, these protoplanets grow into the planets we know today. The inner planets, like Earth and Mars, are rocky and dense, while the outer planets, like Jupiter and Saturn, are gas giants. The remaining material in the disk, the leftover dust and gas, forms asteroids and comets. These are the remnants of the planet formation process, icy and rocky bodies that orbit the Sun. They provide valuable clues about the early history of our solar system. The formation of the Sun is a story of cosmic proportions, a dynamic and chaotic process that unfolded over millions of years. It's a testament to the power of gravity and the fundamental laws of physics. From a vast molecular cloud to a shining star, the Sun's birth is a remarkable tale. Scientists continue to refine our understanding of star formation, using telescopes and computer simulations to probe the mysteries of the cosmos. Each new discovery brings us closer to understanding the origins of our Sun and the solar system it illuminates. The Sun's birth set the stage for the emergence of life on Earth. Without the Sun's light and warmth, our planet would be a cold, barren wasteland. The existence of life on Earth is a remarkable consequence of this cosmic drama. The story of the Sun's formation is a reminder of our place in the universe, a small but significant part of a vast and awe-inspiring cosmos. It's a story that continues to unfold as we explore the universe and unravel its secrets.